I'm going to describe how to solve a set of differential equations, ordinary differential equations. In this case, two equations. They're similar, make it a little easier to input the information for the demonstration. But we have initial conditions. Our independent variable is v, capital V, and at v equals 0, one of our dependent variables, ca, is ca0, and that's a value we know, 21.39. And likewise for cb, at v equals 0, cb is cb0. And so we have a number of parameters, and we have the numerical values, and then we have listed here on the left the iteration scheme. So we're going to step through in small steps for dv. In this case, dv is 0.05. And we're going to step through until v is equal to 20. So 400 steps. And the equations that we use to calculate CA at the next step, so we know, for example, CA0, and then we want to calculate CA1. So we take CA0 and then we calculate these four K values, and that gives us CA1, then we get CA2 from CA1, etc. And here are the K values from the Runge-Kutta method, fourth order. Keep in mind this is going to work if we don't have equations that are very stiff, because I'm doing this calculation with a fixed step size. So what I've done is put in the names for the constants, and then I put in their value next to it. Now originally what I ended up doing was going into formulas under create from selection. In the left column, this is how I name the cells. I won't do it since I've already done it here. But you'll notice this first cell, if we look in the upper left, it's named P. This cell is K, and so forth. And I've put the units here. Again, not important here, but it's a good practice to put units so we don't get confused later. And so over here, where we're going to do the iteration and step through, I've entered our initial value at v equals 0. This is CA0. This is CB0. And then I've put here the equation for K1. So in this cell is this equation that's down here, the bottom left for K1, where CAN is equal to CA0. So if we look at the equation, and I'll move over to make it a little easier to see, S6 times T6, that's S6, and T6, that's CA0, CB0. So those are starting values. And likewise, K2, K3, K4. And then we can calculate CA using the equation that CA1 is CA0, that's S6 up here in the formula for this cell, plus K1 plus 2K2 plus 2K3 plus K4, multiplied by dV, and divide it by 6. So I calculated the new value of CA for a V value of 0.05, and I did the same thing for CB, a very, very similar equation, right? Now what I want to do is repeat this 400 times. And so what I'm going to do is just take these cells, and notice what I've done by filling, every 0.5 we're going to do the calculation. Let me pause and do this up to a volume of 20. So you can see going to cell 406, we have a value of 20. And now I want to copy these formulas. So for example, let me show you a few steps. You notice as V increases, CA and CB are decreasing slightly. Well, I'm just going to again pause and do this all the way out to V equals 20. And so you can see essentially here, these two cells, the cells I made yellow, that's the solution that we're looking for. At V equals 20, this is the value for CA, this is the value for CB. So we solved these two ordinary differential equations by using a fixed step, fourth order Runge-Kutta method. We could certainly use a smaller step size, but we end up getting the same answer within the accuracy we're interested in. So it's certainly faster to not use a small step size, and you can see the calculations are fast. The other thing we can do that's useful, since we're in Excel, we could say what how does our answer change if we change one of these parameters? So for example, suppose we look at changing V0, and what we want to know is what's the new final value, let me call that final, for CA, and the new, let's just do CA for now. So I'm going to put in just a few random values for V0. So what I'm going to do is create a simple data table. Those are the values of V0. So what I want to do is, in this cell, I want to insert the value that's the solution to our differential equation for A. So that's the value in cell S406 we just looked at. And so I want to now do the calculation for a bunch of different values of V0. And so what we do is select these locations, these cells, and we go to data in what if analysis and data table. And what we want to enter is column input cell, and that's our value of V0. And then if we hit OK, you can see it's now calculated. Of course, that V0 is 1, what we started out with, so it calculates the value. And then as V0 changes, the solution changes, and it is solving the differential equations 7 times very quickly to give us a quick way of looking at how the solution depends on this particular parameter. So we can certainly look at more complicated differential equations and solve them in Excel, and the only thing that's a little slow is typing in these values of the k's.